Everyone, thought I'd do a couple of examples just out of our textbook for finding local maximums and minimums or absolute maximums and minimums. Let's start off with example number 1C, and we'll talk again about how we're finding some of our numbers. We talk about critical numbers. So one of the most important things to identify is where is your slope equal to zero, or where is your slope undefined. Since this is a polynomial function of x to the fifth, there is no place where it's undefined. So the slopes will only equal zero somewhere. So again, we take a derivative, make your derivative equal zero, either solve it by isolating x or solve it with some factoring. This little scribble back here says 1 plus x squared, and 1 plus x squared equals zero, never equals zero. So there's no solution there. So it doesn't matter what your algebra is, you get two critical numbers where the slope is zero. So what we do in our table is we talk about the three regions left of -1, between -1 and +1, and then to the right of +1. And we want to know what is the slope in each of those regions. Because from our previous graphs, we would have said if you graph something and has a positive slope, the function is increasing. If you graph the function has a negative slope, the function is decreasing. So again, the way you figure out positives and negatives, pick a number within the region. It doesn't matter what number you pick anything in this region. 5 minus that number to the fourth will be a negative value, which means your derivative is negative. So your function is decreasing. And if you pick between -1 and +1, any number, again, you can't pick the -1 and +1 because those give you zeros. So again, if you pick a half or a quarter or 7/8 or 0.9, whatever you want, put that in the expression and you get a positive number. Our first derivative rule talks about changing from decreasing to increasing. So from the bottom of the curve to the top of the curve, it's the bottom. You go from increasing to decreasing, you're going from the to the top of the curve, back down towards the bottom of the curve, you have a maximum. And then to find the values, you always go back to your function. 2 plus 5x minus x to the fifth. So f of -1 and f of +1 give you your maximum minimum values. And again, the value of the function is the y value of the function, just some of that algebra stuff you learned back in previous classes. So that's example number 1C. Example number 3, it's kind of weird how they started this question as a product. It's really not a product question, and we did that in some of our earlier problem solving as well. If it makes more sense to write it as just a sum and difference, write it as a sum and difference. Take your derivative, make your function equal zero, and you can solve where does your slope equal zero. If you cross multiply with your expression, you find it's 1/8. If you treated this as a fraction earlier on instead of later on in the question, what causes your function to be undefined, or where is your slope undefined? Your slope is undefined when you put zero into the denominator, and it doesn't matter where you kind of see the zero for your denominator. You got two critical numbers this time. Same as the other example we did. So now your regions from -infinity to 0, 0 to 1/8, and 1/8 to infinity. And again, because we really only have one factor, 4 over 1/3 minus 8, or 4x to the -1/3 minus 8, when you're talking about finding your slope, if it's positive or negative, increasing, decreasing, that kind of thing, you only have to put a value into the original function. So again, pick a negative number, cube root it. 4 divided by negative is negative, and negative minus a negative will always be a negative. If you pick a number between 0 and 1/8, 1/27th. If you took the cube root of 1/27th, that'd be 1/3. 4 divided by 1/3 is 12. 12 minus 8 is 4. It's a positive number. So anything between 0 and 1/8 will equal a positive derivative, which means your function is increasing because you have a positive slope. And again, if you pick a number that's larger than 1/8 and you go cube root of whatever that number is that's larger than 1/8, 1,000, for example. If you take the cube root of 1,000, that's like 10. 4/10 minus 8 is a negative number. So every number in here is going to give you a negative slope, which is a decreasing function. And again, then you do the math. You figure out what's your maximum, what's your minimum. Your local minimum is f of 0, and f of 0 is 0. And your local maximum is at 1/8. So you put 1/8 into the function, and you get the answer of 1/2. So 1/2 is your local maximum value. If we keep going with question 3C, as soon as you have a square root function, you recognize you have a domain. You can't take square roots of negatives. So your maximum x value is 4. 4 minus 4 is 0, right? But you can't go 4 minus 5, square root of negative 1. So you know your domain stops at 4. This is a product this time. So product rule, just reviewing product rule, chain rule, lots of good algebra in this question. Common factoring skills, things you haven't seen for a while. So this is a great question. What makes your slope equal 0? Your slope is 0 when the top function is 0. Your slope is undefined when the bottom is equal to 0. So again, you've got a couple of critical numbers, 8/3 and 4. So you make your columns for your factors, 8 minus 3x, and I could have just put 4 minus x in here. In this case, I put the whole factor in, square root of 4 minus x. Notice in the bottom, 4 to infinity. It's not in my domain. There's no function there, so there's no slope there. I actually didn't even have to write that row. I could have just wrote up to and including 4. But anyways, I wrote it in just for that purpose there. Your function, again, what makes it an increasing function is when it has a positive slope. It's a decreasing function when it has a negative slope. And 8/3 then should be a maximum value. So you put 8/3 into your function, do some nice fraction work. 16 over 3 root 3 is a good answer, or 16 root 3 over 9 is a good answer as well. There's only one radical in either one of those. So again, there's example 3C. Question 4A, it's a negative quadratic function, so it's just going to have a single maximum value at the top of the curve. Mathematically, you see you only have one critical number when x is a half. And on the left side of a half, your function's increasing. On the right side of a half, your function's decreasing. So you have a maximum value of a half. And again, you put in your f of 1/2 into the function, do some nice fraction work, and find your maximum value. And for question 4C, nice question, review the quotient rule. A little common factoring of 2x coming out. Simplify what's inside the square brackets, equals 2. 2 times 2x is 4. What makes the top equal 0? 4x equals 0. What makes the bottom equal 0? X squared plus 1 squared equals 0. Well, x squared plus 1 will always be a positive number, and a positive number squared will never equal 0. So you don't even have to worry about any undefined values here. You only have the critical number of 0. Left of 0, right of 0. So again, what impacts your slope? Put a negative number and times it by 4. Put a negative number squared, add 1 and square it again, and always be positive. So your function is decreasing on the left side of 0. Your function is increasing on the right side of 0. From decreasing to increasing, you had a minimum value of f of 0. So your absolute minimum is at -1. Right, real quick video again. Take your chance or take your time to go back and replay a couple of those examples if you need to. Other than that, keep working hard.